Today we're going to be actually using our calculators to find sides and angles. So trig to determine angles and sides. I'm at the halfway point in mine. Look at that. Page 95. Our objective is to use trig to find unknown values. So I'm going to make sure I write down my 3 trig functions. Okay, so sine, cosine, tangent. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent of theta is opposite over adjacent. So this is, excuse me, where we're going to start to use our calculator to find some values. So let's say I wanted to find x. So the first thing I'm going to do is label my sides. 30 is going to be my reference angle. So my hypotenuse is always across from the right angle. Adjacent is always on the other side of the angle from the hypotenuse. So if I start at the hypotenuse and draw my little line across, I'd land on the adjacent side. And opposite is always, if I start at the corner of the angle and go across the triangle, that's my opposite side. So when I'm looking at this, I have h and I have o. So I'm going to use sine to find x. So the sine of 30, that's my angle measure, is x over 10. So my calculator is actually going to help me out with this. Okay? So the first thing I need to do in my graphing calculator is go to mode and make sure that, so I went to mode, and then make sure it's on degree. Okay? To get out of that screen, I'm going to press second mode, and that gets me back to the blank screen. So what I'm going to do is I'm going to solve for x. So to get x by itself, I'm going to need to multiply both sides by 10. So this would be the sine of 30 times 10, and I want to make sure 30 stays with that sign. So my calculator, I'm already in degrees, I'm going to press sine of 30, close my parentheses, times 10. And the reason why I want to close the parentheses here is because sine only evaluates degrees. 10 in this problem is a side length. That's a different measurement from 30, which is an angle measure. And then I put that in my calculator and I hit enter and I get 5. Pretty sweet. So I know that this length right here is 5. Now you're saying, but Mrs. Northrop, this is a 30, 60, 90 triangle. I know off the top of my head that x must be 5. So what happens when we get into some non-traditional angles, some non-special right triangles? Okay, let's say I have a 22-degree angle. And I know that this side over here is 3, and I want to find x. So again, I'm going to start by labeling my triangle. So here's the problem. I'm going to label. So here's my hypotenuse across from the right angle. Following that reference angle is going to be my adjacent side next to it, and then across from it is the opposite side. So I have O, and I want to find H. I'm going to use sine again. Okay, so the sine of 22 equals 3 over x. Well, X is on the bottom. That makes things kind of hard, but I know I could get X to the top if I put sine over 1, sine 22 over 1, and I cross multiplied. So I get X sine 22 equals 3. Now again, X is still not by itself. I'm going to treat the sine of 22 like a number. The whole part is a number, and I'm going to divide both sides by the sine of 22. So X equals 3 divided by the sine of 22. And that's actually what I'm going to put in my calculator. So you guys can see what buttons I'm pressing. I get 8.008. And I'm just going to, for today's sake, I'm going to round to the nearest tenth. Okay. So step 1 I labeled, step 2 pick a trig function. And sine, cosine, and tangent are considered trig functions. Okay, so let's do one more with in a non-special right triangle. Okay, I want to find X again, and again I'm going to be rounding to the nearest tenth because that's what I'm making up for this problem. Typically the problem will actually tell you round to the nearest tenth. So I'm going to label my sides. Across from the right angle is always the hypotenuse. Across, or if I follow that little angle mark across, I'll find the adjacent side to the angle, and then opposite of it is over here. So when I look at this, I have A and I want to find H. A and H are cosine. Fill in all my values. Again, I have X on the bottom, so I'm just going to make a little proportion and do a cross product. Divide both sides by the cosine of 42. And again, I'm going to use my calculator. So 13 divided by the cosine, that's where the cosine is, of 42. And that's 17.5 when I round it. Okay, so that's how I would use this to find a side. Okay, I have a few more minutes. I can do a tangent one too. So let's do a triangle that looks like this. I'm going to label my sides. Across from the right angle is the hypotenuse. Follow that hash mark back and I get my adjacent side. Across from that angle is O. So I want to find O and I know A, so I'm going to use tangent. Well, this is nice. I can just multiply both sides by 5. I get 5 tangent 81 equals X. So again, bust out the calculator. 5 tangent 81. It's going to be 31.6. Okay? So let's say we want to find an angle. So this was how to find a side. Right on this side here. Over here I'm going to do how to find an angle. Okay? And what we're going to need is we're going to need inverse trig functions. So an inverse trig function undoes a trig function. Okay? So if I had the sine of theta and I wanted to know what theta was, I would do, and that would just give me theta, sine -1. And I'll show you where to find that on your calculator. Similarly, if I wanted to find the cosine of theta, I would take the cosine -1 and just get theta. And if I wanted to find the tangent, if I wanted to find theta in tangent, I do tangent -1, and that would just leave me with theta. So these sine -1, cosine -1, tangent -1 are known as inverse trig functions. And they undo sine, cosine, and tangent. Okay? So here's how I'm going to use them. And I'm going to be rounding to the nearest degree for all of these. Let's say I wanted to know this angle right here. And I knew that this was 10 and this was 3. So again, I'm still going to label my sides. It's always step 1. So here's the hypotenuse across from the right angle. If I follow that reference angle back along the mark, I get adjacent, and across from it will be opposite. So I have H and O, so I'm going to use sine. Now, I want to undo sine. So if I'm undoing something, if I'm doing the opposite of something, I need to do it to both sides of the equation. So I'm going to do sine -1 of sine theta and sine -1 of 3/10. And this is where my calculator comes in. So what happens is the sine -1 and the sine cancel on the side, leaving me with just theta. In my calculator, I'm going to find sine -1. That's second side. 3 divided by 10. So to the nearest degree, that's 17 degrees. And I always label theta with a degree. Okay? So I'm going to do another one. Okay, let's say I had these sides and I want to find theta. Again, I'm going to label my sides, so across, label my sides, choose a trig function, use inverse sine, or inverse trig on both sides to solve for theta. Okay? And that's theta, not the cheese, theta. Okay? Theta with a TH. Alright, across from the right angle is the hypotenuse. If I follow the reference angle back along its little mark, I get my adjacent side, and across from that angle is my opposite side. I have adjacent and the hypotenuse, so based on that, let's go back over here, which one has adjacent and hypotenuse? Cosine does. I'm going to be using cosine. Okay? So again, if I want to get theta by itself, I have to undo cosine, so I'm going to use cosine -1. These cancel, and I get theta. Theta equals, and I use my calculator. So second cosine, see how it's cosine -1 in blue there? 16 divided by 20. And I get to the nearest degree is 37 degrees. All right, one more. I want to find theta. I'm going to label my sides again. Across from the hypotenuse is H. If I follow that reference mark back, I get my adjacent, and across from it is opposite. So I have A and O. The trig function with A and O is tangent. So the tangent of theta is 12/13. And I'm going to do inverse tangent on both sides to cancel out the tangent. And I get theta equals So I'm going to do tan negative 1, so that's second tangent, 12 divided by 13. And one of the things I want you to notice, it's 43 degrees by the way, one of the things I want you to notice is I'm not dividing these ratios, I'm just plugging them in as I see them. It's really best that we don't round until the end. So this was how to find